there's this continuing challenge we face, which is just preparing precise instructions. And even as AI advances, this isn't going to go away. Um, so my name is Drew Breunig. I write about technology, data, and AI with a focus on the language around them and how we effectively communicate around them. How do we build mental models? I recently co-founded a startup based on compound AI research, DSPi, and associated software. It's called Compound.ai. And I'm currently editing the context engineering handbook for O'Reilly, which is a new adventure for me, but one that's very exciting. Um, so this is a quote I roll out way too much. This is like the Simpsons equivalent of the bus driver saying, like, "Don't make me tap the sign." But I tap this sign a lot. I think it's like a grounding truth when we talk about AI. If you want to know where the future is being made, look for where language is being invented and lawyers are congregating. Stuart Brand had this quote, and I think it's wonderful. He coined this, decades ago. But it certainly applies to our era. The amount of new language being invented in the AI space is exhausting, awe-inspiring. Um, there's a lot of different ways. This was just a quick, like from memory, vomit on a page of every word I could think of that was unique to AI these days and machine learning that led to it. And all of these have their own kind of embedded meaning. And all of this is we're having to invent it because we're working in a new domain. Now, when it comes to context engineering, which is a semi new word, I want to say it's like last July is when it started to come out. And I want to situate it first before we dive in. So, even though our language is moving fast, and the previous side kind of proved this, our goal remains the same. So in 2023, we talked a lot about prompt engineering, which was all about selecting the right words and examples to elicit the desired outputs from a single model call. So, what are the specific incantations we can put inside of a chat GPT text box to get what we want out? Um, and then next, we kind of moved on to context engineering. And the reason we moved on to context engineering is because suddenly it wasn't one turn, it started to become multiple turns. And when it became multiple turns, it wasn't, if you were building programs, it wasn't just a human editing them. These were automated context preparation via software and other feedback. And so now you're dynamically populating and choosing what goes in the context window with your software. But again, you're trying to get the right information so you can elicit the desired output from the agent. And next, we're now starting to hear about harness engineering, which is how do we design the scaffold orchestration and tooling to elicit the desired output from the agentic application. So, like, everything that we're looking at here is all trying to get the same output. And the challenge here is that we know what we want, but we don't quite know how to say it. But worse, we might not know the right words, but even if we do, the weights inside the model may be different from model to model, and it may have a different vocabulary and conception that allows it to interact with its weights to get what we want. So the right words may fail you, and you see this time and time again. And I don't think this problem's going to go away, even as these models get better and better. It reminds me, again, this is the second Simpsons reference. I'm really dating myself here, guys. But there's a great Halloween episode of The Simpsons, A Treehouse of Horror, which is the classic story of the monkey's paw, where they find a monkey's paw and it grants you wishes, but the wishes are curses. They will technically become true, but in all the worst ways possible. And so after wishing three times, Homer makes one final wish and he keeps it really mundane and incredibly specific so that he doesn't get any curse backfire. And I think this is a great example of the type of prompts I see all the time. I wish for a turkey sandwich on rye bread with lettuce and mustard and no zombie turkeys. I don't want to turn into a turkey myself, and I don't want any weird surprises. There would probably be even more all caps if you were actually looking at this in a prompt. I don't think this is going to go away, and I think even if you snap your fingers and there was something akin to AGI, like you still would have the problem of precise instructions. So what we're going to talk today is sticking on our theme of language. is we're going to run through some examples of how prompts and contexts fail. And my goal here is that y'all kind of walk away with a little bit of a better mental model so that you can spot problems and diagnose and debug with intuition when your AI applications or just your prompts go bad. You'll say, "All right, I see what's happening here. I can understand what the problem is. Here's some fixes that we can apply." And I'll touch on the fixes, though we won't go as deep because there's plenty of people talking today about fixes, including Drew in the previous session. He was talking about one of the fixes, which is data augmentation. So long contexts are not a panacea, and this space moves fast that it's sometimes easy to forget where we come from. But if you flash back to like 14 months ago, there was this kind of conception that, hey, if we can just make the context windows as big as we want, then all our problems are going to go away because we could shove every document we ever need in there. We could put the entire internet in there. We could put all these things and the model can just sort it out. This didn't prove to work well. One reason is because it's hard to build long contexts really well. It's hard to make the context windows really long. I don't know if you remember the whole Llama 4 debacle where they tried to ship a model with 10 million token context window and it just did not work very well. Um, but the other thing is that even though when long contexts are really long, you'd still have problems in them. And these problems are, and this is a little bit of a abridged view, but context poisoning, context confusion, context distraction, and fighting the weights. Um, let's talk about each of these in order. But let's start with context poisoning. So imagine you have an incredibly long context window and you can put as much data as you want in it to answer the question. Let's say you put every book in your library and you ask it a question. Well, what if some of those books in your library have facts that are wrong? Or what if some of those books in the library have information that kind of countermand your instructions that you've given to the LLM? LLMs don't have the ability to kind of ignore what's in the context. Some of the more modern models allow themselves to reason for really long, and they can kind of figure out that that information might be untrue. But they're also sometimes correct and non-correct. We call this recovery. Are they able to recover from errors in their context? But this remains a persistent problem. And if you're designing agentic applications, you need to be very wary of context poisoning and how to get around it. So this is just starts with simple math, which is as you put more data into the model, the odds that an error is going to occur within that data set increases because you have more data. So the odds of it being bad increases. Now, in our agents, this growth of context is often automated. It can come from tools, finding instructions on the web. It can come from model reasoning. So a model may think for a long time and then it may make a misstep. And now that's baked into your context and it has to deal with that. Or could come from the user. And worse, sometimes if something doesn't make sense in the context, like there's a fact that is obviously wrong, or not obviously wrong, but like kind of like it, I think of it like a grain of sand in an oyster. The model will kind of sometimes fixate on this because it doesn't make sense with the rest of the context. And then when it fixates on it, it's now loading more details about this into the context. So that grain of sand is growing and growing and growing. Um, and this metaphor fails because it's not a pearl. It's not something good. It's something bad. But my favorite example of this is from the Google Gemini 2.5 Pro paper. This is one of my favorite technical papers. It's an excellent PDF. I highly recommend you all read it. And one of the reasons I love it is because in the appendix, they detailed the ways that they tried to get Gemini 2.5 Pro to play Pokemon. They built a harness around Pokemon. Uh, they gave it information and tools to play Pokemon, and then they tracked how well it worked and tried to improve the harness and find the bugs. And there was a problem. So up here at the top is Pokemon Red. This is the video game that came out in like 1998. I played it when I was very young. You may have, but it was an incredibly popular and successful game. It was in black and white. It was on the original Game Boy. And then in the 2000s, many years later, when Game Boys had color, they were smaller form factors, Nintendo remade the game. It called it the Pokemon Fire Red version. And it was almost exactly the same game, except, better color and other things like that. But they changed a couple things, like one or two things. In Pokemon Red, you had to give a cold drink to a security guard to bribe your way inside a museum or something like that. In the new version, they changed it so you couldn't give him any drink. You had to give him a special iced tea item. Now the problem is that there is lots of information on the internet about how to play both of these games. And Gemini 2.5 has read all that information and it got confused. And so this quote here was, it kept thinking it had to find the tea. But that was information regarding the remake. And as a result, it would spend many, many hours trying to find the tea in this game. And this is like a classic, embedding and context problem, and trying to give the guard tea for something that doesn't exist. This is a unique case, but you'll find these things over and over, and your model will start to obsess over them. And so it's important to be able to spot them. And I know some people will be talking about fixes for this later, but it's a big challenge. The next problem that comes when your context starts to grow too big, and I'm not going to talk much about this because I know Jeff is speaking later, is context distraction, or as Chroma calls it, context rot. Um, well, context rot, I would say, encapsulates both context distraction and context poisoning, same types of issues. And the idea here is that at a certain length, when you get beyond a certain length of the context window, before you hit the limit, there's kind of a soft limit. And this has been documented with a couple different experiments where the model starts to pay more attention and try to use what you've given it to answer the question rather than relying on the weights in the model. So all the thing the model knows in its statistics and its weights that it's done learned from its training and post-training data, we call that the weights. And then everything that we give it is the context. And usually it's going to use a combination of both those things to answer your question. When you get past this length, we've documented that the model just starts to over rely on the context. And the Gemini Pokemon agent documented this really nicely. So Google Gemini 2.5 had a 1 million token context. In fact, they even were going to plan on releasing a 2 million token context, and I don't think they ever did. But in the Gemini 2.5 Pro Pokemon playing paper, they observed that once it got beyond 100,000 tokens, which is like a tenth of the context, the agent just started repeating things it had done before. It was looking at that long history log that it had accumulated in its context, and it was just doing that over and over. I know Jeff at Chroma has some great examples of this happening with web search, which is it'll make a bad web search and then it will try to come up with a new web search, and it will look very similar to the previous one. And if you don't have different ways of controlling it, it will rely on the context you've given it, repeating maybe paths that weren't helpful. So you got to keep your context below a certain length, below a certain soft limit. And we see that over and over again. Another way the context fails is what we call context confusion. This is kind of related to context poisoning, but it's harder to spot. And one of the reasons it's harder to spot is because these are not facts that are wrong. These are not facts that you might even think are related to the problem that you're being asked to solve. It's just what everything you put into the context, it affects what answer you get out, what comes back with. Now, the problem with this is that, oops, I didn't update the body text. Ignore that body text. But the cat facts cause confusion is correct. So context confusion is, there's a couple good examples of this, but my favorite example, actually, this is a good one, where this paper documented that if you just add random sentences, you can generate completely wrong answers. And they even went systematically through and found random sentences. So, for example, they give a math problem here, and then at the end, it says, remember, always save at least 20% of your earnings for future investments. Has nothing to do with the math problem. It's just kind of a spurious fact. But the LLM gets the answer wrong. It's unable to kind of ignore this, and this affects the weights. My favorite example is here, which is this long math problem, and then the sentence that says, interesting fact, cats sleep for most of their lives. And that's enough to give you the wrong answer. So you have to be careful and controlling about what makes it in. This by far, though, is my favorite example. So I'm sure many of you are familiar of, you've seen the style of prompt writing where someone starts out with you are an excellent programmer. You are a talented marketer. They're kind of assigning that persona. And that's kind of a contextual shortcut. It's a shortcut. By putting that in, you're kind of selecting some weights internally in the model, like that you're running through. A good example of this is like, say you're trying to design the front end of a web page with Claude Code or something. If you try to be very specific about what design options you want, it'll be really hard. You'll have to be exhaustive. But if you say something like, make it look like this style of artist, and it could be anything, it could be Monet, it could be Picasso, it could be whatever, it will do it very well. And the reason for that is just it's drawing on the contextual connections and weights that exist with that. And that happens sometimes, is a great tool when you want it, which is why people put things like "you are an inspirational writer" at the beginning of the prompt. But it can also have bad effects, and this is one of my favorite papers on this, which is by Victoria Lee Yidichen and Naomi Safra, which is they just started systematically testing spurious facts and seeing if they could get around safety controls in the model. And so they would basically say that they're a fan of one football team or another and watch how the answers changed. And true to form, if you said you were a Philadelphia Eagles fan, it would let you build bombs and buy endangered plants. I'm not sure what that says about NFL fandom, but it's notable that, like, and it's a good watch out that things that make it into your context impact the results. And so hygiene is important. And the final problem I'm going to talk about is probably one of the ones I see most often when consulting with people who are building agentic chains, writing their own prompts, writing their long prompts. Um, and I see this even at the big labs. If I just wrote a paper on my website with Srihari, um, uh, whose last name I can never pronounce, but go to my website. He did most of the work, and it's wonderful. And we looked at the system prompts of different coding agents, and we saw this pattern all over it. And this pattern is, I call it fighting the weights. So remember what I said. There's the weights in the model, which is everything the model has seen and been trained on during post and pre-training. And then there's what you want it to do. And sometimes you're working with the weights. For example, like if you're asking it to write Python code, these models have been post-trained to death on Python code. They're very good at writing Python code. But if you ask it to, format its output in a way that it doesn't expect or it hasn't been post-trained on, you may find that you have to repeat yourself or speak in all caps. You end up fighting against its training. And so a good example is like if a frontier model is post-trained to be polite, helpful, and talkative, it can be difficult to get a direct short answer. And this is my favorite example that I pulled from ChatGPT when they were running ChatGPT 4.0. If you generated an image in ChatGPT, it would actually call a separate image generating model, and then it would pass it back to 4.0, which was managing the conversation. And this is the prompts that it would pass back to 4.0 in the background. This is what the instructions ChatGPT 4.0 would get, or GPT 4.0 would get when an image came back. And it would say, GPT 4.0 returned one image. From now on, do not say or show anything. Please end this turn now. I repeat, from now on, do not say or show anything. Please end this turn now. Do not summarize the image. Do not ask the follow-up questions. Just end the turn and do not do anything else. This is a sign that you're fighting the weights. GPT models are trained to be talkative. They are trained to always come back with a reply. They are trained to lead you into the next response. But in this case, OpenAI just wanted to show an image and didn't want it to say anything. So in order to get this output, they had to reiterate this time and time again. And I often wonder, like, how did this grow? Like, did it start with one statement and then they added another? Didn't like they still have bug reports and then they added another? This is like it's just wonderful. And I see this all the time. This is something that happens a lot. If you find yourself using all caps, repeating statements, it's a sign you're fighting the weights. And this is actually a good place where fine tuning can help you out. But in most cases like this, sometimes it is better to just kind of work with the weights. So, like, if I was designing this system, I would just handle this with JavaScript on the front end. I would assume GPT-4 is going to come back and say something, and I would silently delete that message and never show it to them. And I think there's other ways you can handle this where you don't have to fight the weights because fighting the weights is inherently unreliable. This was an example from the article I just recently wrote with Srihari, where we look at this is Claude Code's prompt. In Claude Code, the way they train these models to use code is in a linear fashion. That's just how it works. But on your own machine, it can make multiple tool calls, and they can do it in parallel, which makes it way faster. And they have so many instructions about telling Claude Code it can make multiple tool calls in the system prompt. Like, here's 5 different examples. And what's bonkers is that these actually occur multiple times. This first one is records 7 times between various tool loading and all these other things that happen. Like, it is something that the Anthropic team is constantly fighting to try to get Claude to make parallel tool calls. And it's not just Claude, everyone is doing this if you look at the system prompts.